Let's take an inside look at a rotary compressor. In this cutaway view, there are a number of components that we would like to point out. First of all, this device on the side of the compressor, which looks like a muffler or a filter dryer, it's actually an accumulator. The suction gas comes into the compressor through the suction line, and the first thing that it's going to hit is this displacement screen, which is designed to break up any liquid droplets that might have made its way through the suction line heading back to the compressor. You will also note that there are dual suction lines going into the compressor. This is because most of your rotary compressors are dual rotary, which gives better suction flow and also gives a balanced rotation, which gives us a much quieter compressor. The suction gas is then compressed, and discharge gas makes its way up past the motor and out through the discharge port on the top of the compressor. Because of the low starting torque of a rotary compressor, most systems that contain rotary compressors have a pressure equalization valve, which equalizes pressure between the low side and high side during the off cycle, so the rotary compressor does not have high pressure to start up against on the next cycle. A rotary compressor uses a rolling piston within a cylindrical housing to compress vapor against a reciprocating vane. The spring above the vane holds it in contact with the rolling piston at all times, providing a vapor-type seal between the high and low pressure zones within the compressor. The rotary compressor requires only one valve, the discharge valve. Compression and suction occur simultaneously on opposite sides of the rolling piston, so it takes 2 full revolutions of the shaft to draw in and compress a volume of vapor. The rotary compressor was used in window units and small water source heat pumps units in the past. In recent times, they have seen increased usage in VRF and some residential split systems. Like the scroll compressor, rotary compressors work well on variable speed for part load control. Let's start with the rolling piston at the top dead center. As the eccentric shaft rotates the rolling piston from the top dead center past the suction port begins to open, and a space begins to form between the vane, the rolling piston, and the housing. With continued rotation, the volume of the space increases, reducing the pressure below the low side pressure in the cycle. Vapor is then drawn in through the suction port. This continues for a full revolution until the compression volume is filled with suction vapor at low pressure. During the next rotation, the suction port is blocked by the rolling piston. The low pressure vapor is then compressed in the space between the rolling pin, housing, vane, and discharge valve on the other side of the piston. Initially, the discharge valve is closed, trapping the low pressure vapor for compression. Continued rotation of the rolling piston along the inside of the housing reduces the volume of the vapor, compresses it against the vane, and raises its pressure. When the vapor pressure exceeds the high side pressure, it pushes open the discharge valve. Discharge continues until the rolling piston completes the full revolution and has expelled most of the high pressure vapor through the discharge valve. The discharge valve closes when the rolling piston reaches top dead center.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.